Welcome back everyone to another episode of the Doom series, and in this video we are going to be refactoring and reorganizing our whole rendering framework. Alright guys, so we're going to start by opening up our mesh.h file, and you know that we are going to be changing our mesh a bit, and we're going to be making it so that we can have different vertex layouts. So not every vertex will have the same layout, so we'll need to make our mesh class, mesh struct or mesh module or whatever a bit more generalized. So in here you can see that I've got an enum here called vertex layout, which has two values, which is one is vertex layout plain and one is vertex layout full. Now this kind of enum thing will enable us to have basically the same function but with different layouts. And you can see that now we take when creating a mesh, we take the vertex layout here as well as an input. We also take the number of vertices as an input along with a const void pointer to the vertices, which essentially means like we can pass basically any array as the vertices, and the actual interpretation will be up to the vertex layout that we have got. So if I open a mesh.c here, you can see that this plane, by the way, represents that it's just a bunch of positions with no other data, while full represent it has all of the things that are present in this vertex. Anyways, let's get back here. You can see that we basically here you can see we bind the vertex array and bind the buffer like we were doing earlier, and then we switch depending on the vertex layout. So if it is the plain layout, then we set the buffer data to gl array buffer, and for the size we just use size of vec3, and then we have got only one attribute, which is just a vector 3, which is the actual position. And if it's vertex data full, then we do all of the stuff that we used to do earlier, you know, basically set all 5 attributes, and in the end we bind the element array and everything. And this enables us to basically use our vertex mesh basically with different vertex layouts. So how we'll be using this, we'll understand in the future videos. Anyways, we will also need to use different shaders. So inside of render.h we have got an enum for different shaders. One is the shader default and the other is the shader sky. We'll add more as we need them, and this will allow us to add different shaders kind of more easily. And in the last video we were just hard coding stuff for the sky shader. Now we're going to change this, and by the way, the render draw mesh now also takes a shader as an input. So anyways, let me open up renderer.c here, and what you should be able to see is that here we've got the most drastic changes. We have removed the init projection one because the projection is now controlled by the engine, and we've got another shader here, which is the plane shader. We are not really using this here for now, but we will use this in the future, so we'll explain this more in the next video where and how it's going to be used. So in here you can see that we have got an actual struct here called shader, and we actually don't need to name it since we're only using this once. And this consists of a GL unit, which is actual ID, along with a bunch of GL ints for the different uniforms that we have got. So basically store the uniform locations here, and in the render init we call the necessary functions, and we have removed all of the other unnecessary variables from here. And this, by the way, is an array of shaders, and it has got as many in it as the number of shaders, you know, it is defined in the enum. And here what we do is when we are setting any variable like the view or the projection, we go over each of the shaders, and if its view location or the projection location or whatever is not -1, if it's -1 it means it's an invalid one. If it is not -1, then we just use GL uniform matrix for FV or whatever to set that. And by the way, you need to make sure that this is GL int and not GL uint, because that's what is actually returned, and this can be -1 to indicate an invalid value. And we use similarly for set projection and for set palette index as well. So this basically allows us to automate all of that. And in render draw mesh we use the GL use program with the shader that has been passed as an argument, and then we set the model location on that shader, and we basically do that shader. And here when we are drawing the sky, we use the program for our shader sky.id, so we basically utilize that. We don't we still do the vertex array and stuff manually here. The reason we do that and don't choose the mesh is because the mesh is meant for indexed meshes, but this is not indexed, it's just plain vertices, so we don't really care about that, so we're going to just leave it as like that. And in the init shaders function we have got a bunch of more automation going on here, which will allow us to basically not have to do a lot of stuff manually. So we have got an array of these shader units, and each of that is a struct which consists of 2 pointers. One is to the vertex code and one is to the fragment code, and we basically set this to as many entries as are needed according to our shaders. And for the default we set that to the default vertex source and fragment source. For the sky we set that to the sky vertex source and fragment source, and we can add these just like that. And For actually setting this, we just loop over each of the shaders. We get the vertex and fragment shader from this shader units that we have got. We link the program, we use the program, and then we set the projection location and the model location, the view location, and the palette index location. That if it's invalid, it will just set it to -1 and it will be ignored in the actual set functions. And for the actual textures, what we do is we make sure if the texture is not -1, then we call gl uniform 1i to set the texture correctly, and we just do that each time for each of those. And this is a bit less efficient but a lot more clean, and it's not going to have really a big noticeable impact, and it makes the code a lot cleaner. So we just, if not -1, then we set that to the correct value. And in the end, we don't have the init projection function anymore, since that's just unnecessary. And if I open up Ingenuity right now, the only change we have to do here is make sure that we actually adapt to the new thing that we've got in our renderer and everything. So what we do here is that basically when we are rendering the node, we use the default shader here. And the other thing that we have got different is that when creating the mesh, we use the vertex full layout. So in here, when we are what is this? Let's remove that. And where we are doing the mesh, you can see it's all the way down here where we are creating the mesh. You can see we use the vertex layout full here to make sure that we get the correct vertex layout. And that actually doesn't change anything in how our game plays out or runs. But what it does change is make our code a lot more clean, and we'll be able to use this in the next video to do the next part of our engine in a much more easier and clean manner than what we would need to do without all of these functionalities. Anyways guys, this is going to be pretty much it for this video, and this was just a short one in which we kind of looked over the improvements to our renderer, and I'll see you in the next one in which we are going to be learning about some more techniques to prevent those far away sectors from being visible. So I'll see you in the next one. Make sure to like and subscribe so you don't miss that one, and share this video with other people as well, and bye.